Hello everyone, this is Ramji Sharma. In this video, we'll be looking at the derivative of a function using the derivative rules. So, in particular, we'll be looking at the derivatives using the power rule, the derivative using the sum and difference rule, the derivative using the product rule, and the derivative using the quotient rule. At the end, we'll be looking at an application problem. Our first example has to do with the derivative of an algebraic function using the general power rule and the sum and difference rule. Before we proceed, let me mention the power rule. The power rule is if you have f of x equals x to the n, then f prime of x equals n x to the n minus 1, where n is a real number. It works with any number here. It doesn't have to be always positive integer, but it works with any other number, and that's where a lot of confusion arises. And also remember, the derivative has different notations. This one is the prime notation. The other notations are the Leibniz notations, and the Newton's notations, the dot notations, so many different notations. So sometimes you might see something like d over dx of x to the n equals n x to the n minus 1, which is also the same as this one. So notations are notations, but we have to know how to find the derivative of a function. The first example here I have is f of x equals x to the 3/2. So in this series of examples, we'll mostly use the f of x and then the prime notation, and you might see sometimes the y equals f of x, and in that case you might see dy over dx. So let's find the derivative f prime of x. So here n equals 3/2, which is a fraction. So according to this rule here, we have this rule here. So according to this rule, you have to move the power to the front, which means we have to write 3/2 and then x, and then subtract 1 from the original power, which is 3 minus 2 minus 1. And I hope at this time you know how to add, subtract fractions. So in this case, we're going to write 3/2 as it is, and we're going to subtract 3/2 and 1. So 3/2 minus 1 is going to be 3/2 minus 2/2 if you multiply the top and the bottom by the same denominator, and that's going to be with the same denominator. This is 3 minus 2, which is going to be 1/2. Again, something you are expected to know at this time, but if you are not familiar with adding, subtracting fractions, please review that section before doing these problems. So in this case, it's going to be 3 over 2x to the 1 over 2. And a more common way of writing x to the power 1 over 2 is to put x inside the radical. So you might see this as 3/2 and then the square root of x. But these are the same thing, just in different notations. Now part B. Part B, I have more than one terms. So I have to use the sum rule and combined with the power rule. The sum rule says if you have a bunch of terms, then you just keep on finding the derivative of each term separately. And so it's just similar to the limit. The sum and difference of limits equals the limits of the individual terms. So here f prime of x. So I'm going to go ahead and find the derivative of each of these terms. So 3x squared, so I have a power 2. The 3 outside is going to stay back, so it's going to be 3. And then the power 2 is going to go to the front side of x, which is going to multiply 3, so it's going to be like that. And then we're going to have to subtract 1 from the original power, which is 2 minus 1. So that is the derivative of the first term. Now I'm going to put the minus sign from this line and then write the 5 as it is and find the derivative of x. Now the derivative of x, you will encounter it a lot, and it's worth remembering for the rest of this course. Let me do this here. So the power of x is not visible, but remember, if there is no power shown, that means the power is 1. So move the power 1 to the front and then subtract 1 from the original power. So it looks like 1 x to the 1 minus 1. And then the derivative of a constant, the constant does not have any power. That means the power of x here is 0. So you can think of 6 as 6 times x to the power 0, and if you apply this rule here, you move the power 0 to the front and then subtract 1 from the 0. So that kind of thing will tell you this is going to be 0. But that's kind of a longer route to understand it. 6 is a constant, and the derivative gives you the rate of change. 6 does not change. That's why the rate of change for 6 is 0. Maybe that is a better explanation for that. Okay, now we're going to simplify this. So 3 times 2 is a 6, and then x to the power 2 minus 1, which is a 1, and we don't put 1 in the power, so that's just 6x, and then minus 5 times 1 is a 5, and then x to the power 0. Anything to the power 0 equals to 1. Just remember that. So that's going to be just 5 times 1, which is a 5, and then 0. So this is our answer. So understand, for the future reference, the derivative of x equals 1. So let me put it in this way. The derivative of x equals 1. Or in other words, if you have f of x equals 1, x rather, that means the derivative of that function equals 1. So this is worth remembering for the rest of this course. The derivative of x is 1. Now very quickly you can remember the derivatives of the powers if there are no coefficient in front for the integral powers. For example, the derivative of x squared is 2x, the derivative of x cubed is 3x squared, and so on and so forth. Those kinds of things will become more natural when you do problems like those. For now, let's just try to understand for these particular types of problems here. So again, as a recap, to find the derivative using the power rule, make sure you identify the power. Sometimes there are no powers, that means the power is 1, and what you do is move the power to the front and subtract 1 from that power, and then oftentimes you may end up with subtracting fractions, and also adding, multiplying fractions are also very common in these types of examples. Alright, at this time I would like you to pause this video and work on part C of this problem. Okay, so while you were working on your problem, I kind of cleaned the screen here, so now we have some space. So you ready to compare your answer with my answer here? Alright, so let's look at this. So we have f of x equals x to the 0.7 minus 4 over x. First thing you have to do is just express everything in terms of x to the power n on the top. So if anything is in the denominator, move them up as much as possible. Later on in this video, we'll see how we can handle the fractions in more efficient way. But for now, we don't have any rules for the fractions, so we have to move the terms in the denominators up. Now, if there are constants in the denominator, you don't have to worry about that. So before we find the derivative, I want to prepare this thing ready for the derivative. So x to the power 0.7 minus 4, and I'm going to move the x to the top, so it's going to be x to the power -1. Did you notice that or not? Hopefully you did. So now I'm gonna apply the power rule, which is up there. So it's gonna be f prime of x, and as part of the power rule I have to move the powers out in front. So 0.7 x to the power 0.7 minus 1 minus 4 times -1 x to the power -1 minus 1. So if we simplify these numbers, we get 0.7 x to the power 0.71 minus 1 is a -0.3, minus 4 times -1 is a plus 4, and x to the power -1 minus 1 is a -2. While you can stop your answer here, I want to go a little bit further and write it in a more convenient format. All the negative powers, we usually change the negative into positive by moving these variables to the denominators. So this is going to be 0.7 over x to the power 0.3 plus 4 over x squared. I had to squeeze this thing here, but that's probably the more common way of expressing the answer, but there is nothing wrong with stopping in the second last line here. Alright, again, as a recap of the last example, before you apply the power rule, make sure the powers are always brought up to the top, unless you are using the quotient rules later. Next, these are more similar types of problems with the power rules and the sum and difference rules here. So let's look at the first example of this slide, and that's going to be f prime of x equals. Now I want to simplify this before I go ahead and apply the rules. So square root of x is going to be x to the power 1/2, and 5x is just fine, but if you want you can express the power as 1. So now applying the power rule is n x to the n minus 1. So x to the n goes to that term. Okay, so all the x to the n's will convert into n x to the n minus 1, so you just have to identify n. So in this case the first term has x to the 1/2, so move the 1/2 outside and subtract 1 from 1/2. So 1/2, 1 over 2, x to the power 1 over 2 minus 1, plus here it's just x. So if you recall from my previous example, the derivative of x is 1, so you don't even have to express it and just do the thing. Just write 5 times 1, because the derivative of x is 1. Again, remember, if you have a coefficient in front of x, that's just gonna stay back. However, if you noticed in our second example here, if the coefficient is just a number standing alone, then the derivative of the number equals 0. So as you notice here in this second example, the 3 stayed back, 5 stayed back, but 6 became 0 because 6 was independent or a constant or absolute term. Same thing here. The 5, which is the coefficient of x, is gonna stay back because that is the coefficient, and the derivative of x is 1. Now let's simplify this a little bit further. So it's going to be 1/2 x to the power 1/2 minus 1, which is a -1/2, plus 5. And if you simplify it a little bit further, that's going to give you 1 over 2 square root of x plus 5. Again, I prefer to write in terms of the radicals and the positive powers of x as much as possible, but if you're not comfortable with this type of notation, then you can stop in the second last line. Alright, at this time I want you to stop this video and then work on the second part of the video and come back and check your answer. Okay, so I hope you've worked on this one, and I'm sure you got the right answer. Let's just check your answer with my answer. So f prime of x equals, well, before I go any further, I have to make sure that all the powers are in the right format. So instead of writing f prime of x, I'm just gonna write the original function first of all. So let's just refine or simplify the original function. So let's just clear this one here. So I have part B. I'm gonna rewrite this function in terms of the powers. So the 1 over square root of x. Square root of x means x to the power 1/2, and it's in the denominator, so I'm gonna put it up to the numerator, so it's gonna be negative 1/2 in the power. That's how you change 1 over square root of x. If it is just square root of x, then you just write x to the 1/2. If it is 1 over square root of x, you just make it negative, I mean the power negative. And minus, the second term looks good, so I'm just gonna leave it as it is. And the third is also looking good, so I'm just gonna copy that. So all I want is move all the powers, meaning the variables, to the top, and remove all the radicals notations. Now I'm ready to apply the power rule here. So in each term the value of n is different, so each term would behave differently. So the first one, for the derivative f prime of x, the first one is going to be negative 1/2 x to the power negative 1/2 minus 1. Minus sign is from the previous line. The 3 will stay back because the coefficients will stay back. And then 1/6 is the value of n, so using the power rule, that 1/6 is going to come and multiply 3, and then you got to subtract 1 from 1/6. And then minus 4 is coming from the previous line, and then you got to move 0.5 to the front, so that's going to multiply the 1/4 rather, and then x to the power 0.5 minus 1. So it needs a little bit of cleanup here. So after we clean up all of these, we got 1 negative 1/2 x to the power negative 1/2 minus 1 is going to be 3/2 negative, and then minus 3 and 1/6, you can cancel the common factor, so that's going to give you 1/2, and then x to the power 1/6 minus 1. So if you do 1/6 minus 1, let's do 1/6 minus 1 here. So that's going to be 1/6 minus 6/6, and that's going to be 6 in the denominator. 1 minus 6, that's going to be negative 5/6. So x to the power negative 5/6. And minus 4 times 0.5. 0.5 is half. So the half of 4 is 2, and then x to the power 0.5 minus 1 is negative 0.5. So this is fine, you can just leave your answer here, but you know, I would like to change these negative powers into positive all the time, and then if it is power 1/2, which is the case in the last one, I want to change it into radical. So it's going to be negative 1 over 2 x to the 3/2. I moved it to the denominator because of the negative power, minus 1 over 2 x to the 5/6, and then minus 2 over square root of x. So the power of 0.5 is just the square root of x. 0.5 is 1/2. So again, something not absolutely necessary, but it looks good if you can put the answer in this nice format. Next we have the product rule. So find the derivative of the algebraic function using the product rule. Now what is the product rule? So if you recall, either from reading the book or some other places, the product rule looks like this. Let me write it here. Product rule. If you have f of x equals the product of two functions u of x times v of x, where u and v are given in different formats. For example, in the first example, u is the first expression and v is the second expression. So these are expressions of x. If that is the case, then f prime of x, so that gives you f prime of x equals ux times v prime of x plus vx times u prime of x. So the idea is to differentiate one function at a time and add them up together. Alright, so let's apply that formula here. So part A, you have u of x. You can always think of u of x as the first expression and v of x as the second expression. So u of x equals 3x squared minus 2. And u prime of x is going to be the derivative of this thing, which is 3 times 2 x to the power 2 minus 1. So that's going to be 3 times 2x minus 0. So that's going to be 6x. Similarly, v prime of x, well, let's find the v of x first and then find the v prime of x. So v of x is going to be v of x. v of x is the second expression, which is 4x minus 1. And v prime of x is going to be just 4 because the derivative of x is 1. Remember that. And the derivative of 1 is 0. Now putting them all together into this formula, we have f prime of x equals, so we have u of x times v prime of x. So u of x is 3x squared minus 2 times v prime of x is 4 plus we have v of x, which is 4x minus 1 times u prime of x is 6x. So you can just leave it like that if you don't want to simplify this any further, but it's always good practice to simplify the answer and put it in the final simplified version. So if I multiply the 4 inside, I have 12x squared minus 8 plus, now I can multiply 6x inside, so I'm going to have 24x squared minus 6x. So if I combine the like terms and move the highest power to the front, I have 24x squared, and then I have a 6x, 24x squared and 12x squared. I think I'm gonna be able to add them together because these are the like terms. So let me just change that. So 24 plus 12 is going to be 36, I believe. So that's going to be 36x squared, and then minus 6x and minus 8. Minus 8, where did the minus 8? Yes, the minus 8 is going to stay back, so minus 8. So that's the answer for this problem. Okay, now you can pause this video for a while and work on this second example. Alright, so I hope you had a chance to work on this one. So let me go ahead and show you the answer. So part B, u of x is going to be 5x plus 1. That gives you u prime of x equals 5, because 5x, the derivative of 5x, the derivative of x is 1, and 5 is going to stay back, and the derivative of 1 is 0. Similarly, v of x is going to be square root of x, and v prime of x, if you look at one of our examples, the very first example, no, it's not a very first example, but it is one of the examples here. So square root of x is going to become 1 over 2 square root of x right here. So that's why I'm just going to copy that result from there. So it's going to be 1 over 2 square root of x. If you're interested in working it one more time, you can just go ahead and work on your own, but it is already done in the previous example. So putting them all together into this formula, we have f prime of x equals u of x, which is 5x plus 1 times v prime of x, which is 1 over 2 square root of x, plus v of x, which is the square root of x, times u prime of x is 5. So you can just leave it like that, but you can combine these together, multiplying the second term by square root of x, 2 times square root of x, and then rationalizing it that way, and then adding the terms together. So it's going to become 5x plus 1 plus, if I multiply the second term by 2 square root of x, that's going to be 5 times 2, 10 square root of x, and square root of x is going to be x over 2 times square root of x, and then 5x plus 10x equals 15x plus 1 over 2 times square root of x. Again, something you might consider doing it, but you can leave your answer right here. Alright, so these two examples here demonstrate the product rule. So in the product rule case, you just have to identify the u and v and just apply the formula. In the process, you have to find out their derivatives and then simplify your final answer as much as possible. Well, let's look at another set of problems here. This time we're going to look at the quotient rule. So what is the quotient rule? The quotient rule says if you have f of x equals a quotient u of x over v of x, then the derivative of that function is going to be v of x squared in the denominator, and v of x on the top times u prime of x minus u of x times v prime of x. So that's the formula that you need to remember. So you just have to identify u and v and find their derivatives and then plug them back into the formula. In the first example, I have u equals, or u of x if you like, so if you want to express it in terms of x, so that's u of x. In some books you might just see u instead of u of x, and that's okay. So u of x equals the top, which is x squared minus 1, and that gives us u prime of x equals so that's x squared, so 2x. The derivative of x squared is 2x and the derivative of 1 is 0. Similarly, you have v of x equals 2x plus 3 and v prime of x equals 2, because the derivative of x is 1 and the derivative of 3 is 0. Now putting them back together into this formula, we have f prime of x equals, in the denominator we're going to square the v, so v is 2x plus 3, so I have 2x plus 3 squared, and then on the top I have v of x, which is 2x plus 3 times the numerator times the derivative of u of x, which is 2x, minus, now I have to put the u of x, which is x squared minus 1, times the derivative of v of x, which is going to be down here 2. So if I simplify this, I'm going to have 2x times 2x, 4x squared, plus 3 times 2, 6x, minus 2 times x squared, and a minus there, so 2x squared, and then minus and minus is a plus, 2 times 1 is 2, divided by 2x plus 3 squared. And if I simplify this a little bit further, I have a negative 2x squared. Oh no, that's a 4x squared minus 2x squared is a positive 2x squared, so I don't even need that negative sign there. So 2x squared, or maybe just positive 2x squared, plus 6x plus 2 divided by 2x plus 3 squared. Alright, so that's your answer for the first one. Now I would like you to pause this video and then work on the second example. Alright, so I hope you did your work for the second part. So let me just try to finish this one. So for the second example, we have u of x equals 4x plus 1. So that gives us u prime of x equals 4. Similarly, v of x equals x plus 2. So that gives us v prime of x equals 1. Now putting them into this formula up here, so you got f prime of x equals v squared in the denominator, which is x plus 2 square, and the numerator we have v of x, which is x plus 2, times u prime of x, which is 4, minus u of x, which is 4x plus 1, times v prime of x, which is 1. So after simplifying the numerator, you have 4x, 4 and x is 4x, so that's going to be 4x plus 2 times 4 is 8, minus 4x times 1 is 4x, minus plus 1 is a negative 1, divided by x plus 2 square. And if you cancel the 4x and 4x and subtract 8 and 1, that's going to give you 7 over x plus 2 squared. Was that your answer? Okay, I hope that was your answer. Now we're going to look at the application problems. So the first one we're going to look at is the marginal revenue, and then we'll look at the marginal demand. The instantaneous rate of change of the demand function later. So in this example, we're gonna look at the revenue function, which is given by r of x equals 5x minus x squared over 312, and we got to find the marginal revenue. So compared to the algebraic problems we did earlier, this one's not going to be that difficult. It's much simpler than that. So we have to find the derivative of the revenue function first of all, because the marginal means the derivative. So let's find the derivative, and then we have to implement this last information given to us. So r prime of x is going to be the derivative of 5x minus x squared over 312. So 5x becomes 5 because the derivative of x is 1, minus the derivative of x squared is 2x, divided by 312, which is basically gonna stay back. 312 is gonna stay back because it's the coefficient. So you can think of x squared over 312 as 1 over 312 times x squared. So this is a very small number here. That's why you don't have to worry about the number being 0, because it's not an absolute term. It's just the coefficient. The coefficient's gonna stay back. Alright, so now we're gonna find so this is the marginal revenue function. Now we're gonna find the marginal revenue from the sale of the 11th item. So this is gonna be a little bit of confusing if you are not understanding the definition of the derivative. The derivative is the instantaneous rate of change, which means you make a small change in the x value and then you find the corresponding change in the y value, and that difference of the ratio of the difference is going to give you the derivative. But here we are talking about the items. So the smallest item you can ever think about is 1. So you basically make a change in x by 1. So you can produce one more item, and that's the smallest change you can ever get in terms of business. So to get the 11th item, you have to start from the 10th item, and you increase 1 from the 10th item, and that's going to give you the 11th item. That's why your starting point is 10, not 11. So you really have to find the derivative at 10. That's where things begin, and then you increase x by 1, and then you get the 11th item. So you make sure you understand that, and that's going to be 5 minus 2 times 10 over 312. And if you simplify this in your calculator, you should be getting some number here. So that should be 5 minus 20 over 312. Let's do it in our calculator here. So let's just clear that. So 5 minus 20 over 312, and that's going to give us 4.9358. So it's going to be 4.94 up to 2 decimal places, so 4.94. So that's your answer in this case. Alright, so we got that application problem here. Now the last example I have after this is another application problem, which is to find the instantaneous rate of change of the demand function. So the question is, given the demand function d of p equals negative 3p squared plus 140p plus 6, find the instantaneous rate of change of the demand function when p equals 10. So let's find the derivative d prime of p, which is going to be the derivative of this function. So that's going to be negative 3 times 2, which is a negative 6p plus 140. The derivative of p is 1. Remember here the x is p, so the derivative of x is 1, which means the derivative of p is also 1. And then the derivative of 6 is 0. Now we're going to do the evaluation of this derivative at 10. So that's going to be negative 6 times 10 plus 140. And negative 6 times 10 is going to be negative 60 plus 140. And if you do this calculation, you should be able to find the final answer. So it's going to be negative